Hello again. Well, it's been a long time since the last video, much longer than I expected it to be. As you can tell from the title, the easy part is having an idea, the hard part is getting that idea to fruition. Anyone planning a Kickstarter ought to think about that. This synth still looks the same, pretty much. It's still on breadboards. I did build a prototype. This is prototype 1 or 0.1, and at first I thought it was okay, but it was actually a failure, and I realized that only when I started to record it to make a video, which was about about a month ago. Turned out it sounded rough, and that was because I'd started off using a system for supposedly simplicity's sake of having the IC, the microcontroller, generate the waveform digitally. That led me down actually a rabbit hole or a garden path of trying to get a good digital waveform, which is a lot more complicated than you think it is. And I ended up in a minefield of things like bandwidth limited impulse trains and whatever, because of the problems with aliasing, which is when the digital signal is creating false overtones which sound like ass. So, although this does, however, present a kind of idea of the form factor I'm going for the synth, the aim of the synth is to be small, cheap, and easily constructed, because there are huge numbers of modular synths out there and people building big analog synthesizers that cost a great deal of money, and I want something cheap because I'm always skinned, and I want something that can be easily put together. Now, bear in mind, if this was on a PCB and using surface mount components, everything would be like a quarter of the size, so there'd be a lot more room here. Might make it a bit bigger. On the back, Midi ports and USB only for power. I'm not getting into USB connections to computers, they're far too complicated. That's the line out, which you can see is a stereo mini jack, although it's only a mono signal at the moment. Stereo for future expansion. And I've stuck with the 4 knobs principle, which I started off with my little dev board here, if you want to call it that, which has just stopped working actually. So I've had to put in a temporary switch here because this one, which is supposed to do loads of stuff, doesn't work anymore, and I can't be bothered to fix it right now because I want to make a video. So you've got 4 knobs. That's obviously not enough to control a whole synthesizer, so they're in pages. Now, on the one hand, this does make it a bit less hands-on. On the other hand, it's not too bad if you're consistent about what's on what page. What page you're on is set by color, which you can see on this version, the actual working version. It's a tricolor LED. So you've got, as you cycle through, the LED changes color. Now, there's a couple of reasons for this. First of all, it's much easier and cheaper to connect up like that. to like for circuit wiring. Secondly, I think it's actually more memorable. People tend to remember colours quite well. I've found that while I've been testing this, I've rapidly come to associate the page colours with the function. So blue is the oscillator. Let's go through them. Green is filter. That's the main filter controls. Cyan is the modulator. So that does vibrato, pulse width, filter. And then we've got the two envelopes. Red is the amplitude amplitude modulator, and then pink is the filter. Sorry, envelope, and then pink is the filter envelope. Yellow is not anything at the moment, and white is the most general stuff. That's master volume and tuning. And then we're back to blue. The other switch just takes you back to blue every time, which I find is quite handy. And I've actually found it's pretty rapid to set up a patch using this method. Now, it's not a hugely complicated synth anyway. At the moment, it's a single oscillator, a filter, an amplifier, and that's it. And that takes me back to really the philosophy of the thing, which is that it's not supposed to be all singing and all dancing and do everything like a modular system, which costs a great deal of money. This is more in the spirit of my first synthesizer, which was the Gen SX1000, or maybe something like a Moog Prodigy, or even a Sequential Pro 1, which was all the basics put together into a fairly low cost package. I mean, low cost's relative, but nowadays low cost is very different to what it was in 1980. But that's the general idea. Now, I'm still umming and ahhing about oscillators, and I'll come to that when I get onto the circuit. I think one is enough for a very basic synth. I am looking at a kind of ensemble mode, which isn't completely independent oscillators, but you might get one or two extra detuned oscillators, but we'll see. So I gave up on the digital waveform generation, which was silly anyway. I never intended it to have that. What it has now, next to the filter you saw last time, which I've slightly modified, here that's the filter. This, I'm only using one op amp. Can you see that? There's one, that's a quad op amp. Oh, that was me touching it. Did you hear that? I'm only using one op amp at the moment on there, but it's a wave shaper. And what that does is it takes the input wave, which is a square or pulse wave. Let's draw this. It takes a pulse wave, or we'll call it a square wave like this, and then it oh dear, there we go, and then it changes it into a ramp. So for a Sawtooth, what I actually do is feed it a very, very short pulse like this. It's hard to look at the paper and the screen at the same time, and then turn that section of it into a ramp. Now, for a triangle wave, which you will hear in a moment, we take a square wave like that, and then we ramp up and we ramp down. So basically this point here, the duty cycle of the wave, sets the two ramps. Now, an original plan was to have continuously variable ramps. I've always wanted to do this since 1980 or whatever. So that, for instance, if you had a wave like this, let's say a pulse wave like that. Am I going through the paper? I bet I am, aren't I? Then you'd get something like that. Now that's still a potential, but I've actually found from experimenting with it, it doesn't actually sound that great. It's not that interesting to listen to anyway, and may not be worth the hassle. So what I'm doing at the moment is just feeding it the same ramp duration, and it actually there's a trigger pulse at each end sorry, a trigger pulse there and a trigger pulse there that pulls the wave in either direction. So when you want a square wave, you put in a trigger pulse there. That puts in a massively fast ramp, so you basically get a square. So at the moment there's one oscillator. Now, using that system, I can probably make more than one oscillator out of this. The microcontroller has plenty of spare pulse width modulators to do that. The issue comes back to my smaller, cheaper approach, which is that each oscillator requires at least another op amp, and it's a sort of cost-benefit thing. The major problem is that to have completely independent oscillators, I also need another two digital to analog converters to produce different ramp lengths. So what I might do instead is just have them all use the same ramp length and be slightly detuned. We'll see. But anyway, I wanted to get on and post a video because it's been ages, and I've just been, in a sense, circling the drain with this, where you keep sort of listening to it and you change something and then you think of something and then you spend a week writing bits of code and then it doesn't quite work out as you plan. One other thing I did figure out is I really wanted an independent volume control which isn't computer controlled, so you can just reach for it. So there'll be one of them on here as well, so it'll be a bit longer. I might also, probably will, change it so that it's flat rather than being like, oh dear, not on camera. There we go. So that it's flat like that, so the knobs are pointing down into it rather than like that. Because when they're on their side like this, it's a bit more of a fiddle, but more than that, if you're pushing a button that way, you're continually pushing the thing off the table where it is. Whereas if you're pushing vertically, of course, the tabletop gets in the way, like that. So that's where I am at the moment. Now, here's some sounds actually. Let's do some sounds. If I switch it on and off, oh, it'll take us back to the default patch. And sorry, just realised that I'm sorry, I just messed up my computer. Anyway, so it should have the default patch now. So we can vary the pulse width there. Now this will change us to a Sawtooth. I'm not supposed to do that. Hold on a minute. And we have a wire pulled out. Where does this wire go? Ha! Oh well, live fixing of things. I need my other glasses on. Hold on a minute. That's the input. I thought this was, I can't remember what it does now. So you can still hear it, funnily enough, but where does yellow go? Those are the two trigger inputs. They're okay. Oh, live fault finding. Blue is the output of the pulse width modulator. Those two are the control voltages. Okay, so... Oh, yellow's the filter, I think. Let's look up what that is. I've got that listed as from square. This is my drawing of what the oscillators do. That's the reference input from the square wave, which is coming out of the pulse width modulator. What? That's not it. I fear I might have to stop video recording while I figure this out. I think it's supposed to go over there somewhere. Oh, I think that's the course ramp control, which should go... No, that's not it. That's ramp fine, that's ramp course. Reference plus from square. I don't remember what this does. PW pulse width modulator 5 out. I know what it does. I'm just trying to figure out where it's supposed to go in the circuit. The what this does is that the square wave. Let's show this. The square wave goes into a digital to analog converter, and then is reduced relative to the center, so that it comes out as like that, which is the course ramp control, which is the but I can't remember where it's getting the square wave from, because that's the output of the square wave there. Oh, I think it goes there. Let's just pull that out and see. That's not right, is it? Well, let's just switch to the So you can see the waveform now. There we go. So there you can see the Sawtooth, with that pulled out, it's never getting the control voltage necessary to pull it down. But here's an example of how the circuit works, because if we switch back to square wave, it still works. And that's because it's getting the up pulse and the down pulse. It's getting the reset pulses. But if we put that there, it's now also getting the gradual control voltage. And there, by the way, is the triangle wave. Now, while we're here, and we've fixed it, this is the filter. And that's the filter resonating. Just before I continue, that illustrates my control method. When you change pages, oh stop it. When you change pages, oh dear. This is why I want to get another prototype built, because breadboards are tricky. When you change control pages, obviously it's no use having everything jump to where the knobs are. So what happens is you have to sweep the knob to pick up the voltage, so to speak. So if it was set to 50%, you'd have to sweep the knob past there, and then it would start following the knob. Everything was working a lot better before I moved this to do the video. Okay, so now, like all triangle waves, that's rather feeble and faint, but we can make it self-oscillate like that. Which gives us some nice spacey 1950s sounds. We can also completely turn the oscillator off, and then you can hear the glitching actually from wires not quite making contact. So we get some self-oscillation there. Now we've also got filter tracking, which means it should follow the keyboard. One of my wires keeps popping in and out, doesn't it? Everything was working fine before I started videoing. There we go. So, what else can we do? Now we can put in some filter modulation, if we like. And if we go back to a square wave for now. Oh, it's that one, isn't it? And turn down the resonance a bit. This is getting silly now, isn't it? And if we remove that, we can have some vibrato as well. And if we go back to the square wave, we can have some nice pulse width modulation. And that knob doesn't do anything. Finally, I don't think I should go much further because this whole thing's going to stop working in a minute. But this is the envelopes working. While we're at it, this is the filter envelope. Now we go back to the filter and we turn up the envelope, which happens to be that one, and turn down the main cutoff, which happens to be that one. And then we go back to the envelope. That's the sustain level. It's ADSR like usual, and we can do that. And now I happen to like those overdriven filter sounds, but not everybody does, which is why you have an adjustable input to the filter as well as the output. So one of my wires has gone funny again, hasn't it? And this is why you've got a programmable volume control. So that you can have a quieter input to the filter, but then a louder output. Unfortunately, one of my wires is popping all over the place again. As you can hear, and the filter's gone funny again. So, what have we learned today? We've learned that my breadboards are falling apart. It has not been like this until the moment I started videoing, although I did move it around a lot to put it on this chic upside down table mat. Time for the second prototype, I think, so that things at least don't fall apart. You've also probably heard throughout the video some background noise. That again is due to this nest of wiring. But it's been like that because I've been doing quite a lot of umming and ahhing about exactly how to do various parts of it. However, at least you've heard it playing as a synthesizer now. And if you've got any comments, please share them with me in the comment section. And of course, like and subscribe.